Okay, so for today, quick reminder of yesterday. You couldn't leave it that way because it's got an I in the denominator. An I really is a square root, right? You can't have square roots in the denominator, so you'd have to multiply top and bottom by what's called the conjugate. What's conjugate? You are right, 2 plus I. Don't have to even do this one, just want to remind you that's what you would do. Okay? All right, so I'm going to put the fraction bars, or sorry, the parentheses that are there, even though you can't see them. They're implied parentheses. All right, let's move on. Take a look at this one. This would all be a review of yesterday. I don't need to do any of these. I think that was really easy. Just a quick reminder, what was that the symbol for? Conjugate. Right. Now, the new thing is about the complex factorization theorem. And I will summarize it for you. You need to remember everything you learned in honors higher algebra in one day that you learned in like 3 weeks. All right, so I'm going to teach you. Don't worry. So that's summary. That's the summary. Here's typical questions that you'd have to be able to do. You'd have to know what synthetic division was. You'd have to know the difference between a zero and a factor. You'd have to factor things over the complex and the real numbers. So much stuff. So here we go. Get room to write. I know you know this. X squared minus 36. I know you can all factor that. So please do it. It'll just help you get kind of in the right mode. And if I said that equaled 0, then this equals 0. And then let's just analyze a little more thoroughly. Did you get x plus 6 and x minus 6? Okay. Then would you agree that these are what are called factors? Yes. Then what are the roots? Those are not roots. They're different. The factors, we've never said there's 4 names for these things. One of those factors. No. There was roots, zeros, x-intercepts, and solutions. Okay, so back to what the heck is one of the factors? No, one of the roots or the zeros. Yeah, x equals 6 is the root. And then that one goes with that one. X equals negative 6 goes with that one. Why? Because it's the thing that would make it equal 0. Okay, so what if I told you that I had a polynomial and one of the factors was a? What? Then you should be able to tell me, oh, I just said it wrong. One of the roots is a. If I have a polynomial and it has a root of a, then do you get the factor would be what? X minus a. Getting the idea here? What if I said the root was 7? Well, then the factor would be x minus 7. What if I said the root was Bob? X minus Bob. Very good. I think you get the idea of between the difference between roots and factors. Next thing, you've done this for a bajillion years, but was anybody nice enough to teach you what happens if you change this to a plus? That you can still factor it? Oh, I think I taught you that. We'll see if you remember it. X squared plus 36 would be the same kind of thing. X minus 6, x plus 6. But you need something else. How am I going to get that negative 6 to turn into a positive 36? If I multiplied negative 6 times 6, it will be positive 36. Think in context of yesterday. We have to have a negative somehow. The I, you got it. The I's have it. There needs to be an I here and here. Think about that for a second. Why does that help? Because then, when you multiply this out, do you get that the middle terms will still cancel? At the beginning, it's still x times x, which is still x squared. The only thing that's really different is at the end, you'll have negative 36i squared, which is really negative 1. So then what's this really? Plus 36. It worked, see? All right, so we had to throw in the I to make it work. Let's see if that really stuck. X squared plus 144 equals 0. Would you please find the 2 roots? And it's not 12 and negative 12. Would you find the 2 roots and the 2 factors and realize that they're different? Did you factor it, sir?
I did.
And what did you get?
I got x plus 12
That's a good start, but it's not right.
squared.
It's not right either. I think you forgot what I put in there.
Yeah. Okay.
That's what you get. X plus 12i, x minus 12i. And those are the whats, Mr. EL? These guys are called the whats? The factors. And then that begs the question, the other thing. What's the other thing called? If they're not factors, then they must be roots. Okay, so the roots are two things. Negative 12i for this one, and positive 12i for that one. All right, so I know that you guys know that the quadratic formula is a thing, and it's a helpful thing, and it's especially helpful if you can't factor it, because if you can factor it, you should. All right, now what if a kid had taken this problem right here and didn't know that little trick about how to factor it with the i's? Do you get that they could have used the quadratic formula for it? Let's take just a second and remember this later when I'm asking you how to factor something. Last hour, it was like, I'd never said this. All right, so how do you factor this again? Well, you use the quadratic formula to find the roots, the zeros. We already found them. They're 12i and negative 12i, but you're going to find them again using x equals negative b plus or minus square root b squared minus 4ac all over 2a. Would you please do that now, except stick in a is 1. What's b? 0. What's c? 144. Do it. Use the quadratic formula, because even though this has a negative under the square root, we can still do it. And the b being negative really is nice, because then it's 0 plus and minus the square root of 0 minus 4 times 1 times 144. And I know that's a bit icky, but we'll do it in a second here. All over what? 2a, which is 2. Now 4 times 144. Anybody got it? So it's plus and minus the square root of negative 576 all over 2. Then I'm going to clean up that negative part and say plus and minus I root 576 all over 2. Anybody want to take a guess, considering what we know the answers are? What do you think the square root of 576 must be?
24.
24. I agree. Because then you can divide it by the 2 and get the 12 that we know that we want to get anyway. So the square root of 576, if you'd used a calculator, would have come out to 24. And then it's I times 24 over 2. And then if I simplify that, plus and minus 12i. Do you get that then I could say, oh, so since these are the roots, then the factors must be x plus 12i and x minus 12i. That's another way you could have done that one. So if you ever get stumped and you're trying to factor something that's really weird, the quadratic formula can factor it for you. Let me give you an example. X squared plus 3x plus 2. If you can factor it, you should. Go ahead, factor that one. Do you have a smartphone? Do you have a smartwatch? Yes. Okay, thank you. Thought I was seeing a smartwatch being employed, but you had your hand, just had your hand in it. I'll explain it later. Mm-hmm. Okay, so this one does factor x plus 2, x plus 1. So what are the factors? X plus 2 and x plus 1. What are the roots? Negative 2 and negative 1. What do the roots do? They make it equal 0. That's why they're called the zeros. So if I wanted to stick negative 1 in here, it would make this whole thing equal 0. Okay, good enough. I think you get the idea. So now, what if it won't factor? X squared plus x plus 7. That doesn't factor. Or does it? It doesn't factor the nice way. But use the quadratic formula to factor it for you. This feels like just like one of those top 20 things where you got to keep simplifying it. What a pain. How am I supposed to make that into a factor? Well, those are the roots. How do you make it into a factor, though? Remember me saying that what if the factor was Bob? Sorry. No, what if the root was Bob? Then what's the factor? X minus Bob. Okay, so what if the root is some weird thing like that? Would you please write what you think the two factors are? It's x minus on both of them. X minus negative 1 plus 3I root 3 all over 2. And negative 1 minus 3I root 3 all over 2. Whew, that's icky. That's complicated. That's honors pre-calc level. You factored it. It's gross, but it would work. All right, I'm going to give you a little blast from the past and see if you can handle this while I pause for a second after I give you this one. Ready? Let's see if you remember how to graph something like that. Make a quick sketch. Maybe you think it looks like that. You'd be completely wrong, but something like that. All right, I'm going to pause for a second while you give that one a try. All right, so I'm hoping you remembered a negative in front means something. What does it mean? That it's going down on the right. How many of you remembered to make it go down on the right? Awesome, that's important. So however it ends, it better end going down. It might end with a bounce and then going down or something, but the right side needs to be going down. Okay, so I just put a little sign like that to myself. Next, did any of you take a second and figure out that the lead term would have been negative 2x to the third? What? Because that times that squared times that. That tells you what? That this is an odd one, which means the ends have to go opposite ways, which means that end goes up. Did you catch what just happened there? I did a quick multiply on what would have happened if I multiplied this thing all the way out, and all of those pieces together lead me to believe that I would have had negative 2x to the third. And then that tells me, since there's an odd number up here, that these go in opposite directions from each other. The right side is so simple. It's just this. If there's a negative in front, it's going down. The left side, much more complicated. You got to go through this process where you find the lead term, and then its degree tells you if it's odd, they're opposites. If it's even, they're the same. All right. Next, how many of you remembered that this x minus 3 would create an important spot right there? You got that on your graph? Because there's an x minus 3 here. That's a factor. And also, this is squared right there, which means this is a bounce. This is a review of a huge chapter of honors higher algebra that you took last year. Okay, so if it's bouncing there, where else is it going through? Right here, which is at -7. It has to go through there. And that one is not have a power up here, which means there's actually a 1 there, which means that it just cuts through there. So how do I put all this together? It cuts through there, has to be going up on this side. It bounces off there so that it's going down on the right. How many of you had a bounce right there on your picture? Awesome. That's overall what you need to remember. Now, how do we make this pre-calc level? Now we throw in imaginary stuff. Remember that you can't see imaginary stuff on the graph. It's kind of like unicorns. You know they're out there, you just can't see them. Or leprechauns. I mean, I've seen the rainbow. I know that the leprechauns are out there at the end of the rainbow, but I just have never actually seen one. Okay, so imaginaries are like that on the graph. You know that they're in your graph, but you don't know where they are. You can't just say, oh, look, that's where my imaginaries are. It doesn't work like that. Okay, but here's something I could say in an honors pre-calc test. If this is the lead term, and I know x equals 2 is a root, and I know x equals I is a root, then I can figure out a lot of stuff about my equation. Do you remember that imaginaries on a graph always come in packages of 2? So as soon as they say x equals I is a root, I know that x equals -I is also a root. I want you to understand why there's always 2. If there's going to be any imaginaries, it's going to be in packages of 2, like either 2 imaginaries or 4 or 6. You'll have to have a pass to be able to get credit for being here on time. So get your teacher to send you an email or something. All right, send me an email, not you. All right. So next thing is if these 2 together are roots. Because, wait, why was it that there had to be 2? Do you remember, if I just give you the simplest explanation, it'll be like this. If you graph that thing, do you get that that's going to be a parabola? Do you get that its y-intercept is 10? Do you remember that part? The y-intercept is where x equals 0. See, do you get it's going to be something like that, maybe? Doesn't have any real roots. Does it imagine imaginary roots? Yeah. Can you see them on the graph? Nope. Can't just say that's where your imaginary roots are. This doesn't work that way. Okay, so I know it's got imaginary roots, I just don't know where. If it's got imaginary roots, do you get it has only 2 roots? Because that's even. This number here is even. That says that there's 2 roots. And if it's got imaginary roots, do you get that it have to be 2 of them? All right. Here's another way to think of this. If I was going to do the roots, I'd do x equals -b. Plus or minus square root b squared 25 minus 4ac, 4 times 1 times 10, all over 2a, which is 2 times 1. Guess what's going to happen under here? Going to have a negative, right? And if I have a square root of a negative, then I have I, right? What's always right in front of that? Plus and minus that. There's always going to be 2. If you have one imaginary, you're going to have another one. Okay, so if you didn't learn that before, learn it now. If there's ever going to be one imaginary, there's got to be a second one. And why? Because this plus and minus in the front's the easiest way for me to explain why. Okay, so back to my question from the typical test question. -3 x to the 5th is a lead term. That's a root, and I had to know. So therefore, x equals -I would also have to be a root. You have to be able to put that in. And then you'd be able to say, what's the answer? Well, here, I'm going to write it. Y equals, I'll get you started, x minus 2. Keep going. Write what you think the answer would be. What's this equation? It starts with x minus 2. But there'll need to be more stuff in here. I have to add a lot more to my answer. Like maybe there's a lead coefficient. How many of you figured out there'd have to be a -3 somehow in the front? Remember that? Because it said that was a lead term. So it has to be a -3 in the front eventually. How about this? Could this possibly be the right answer just all by itself? No. How many roots am I supposed to have? I'm supposed to have 5. And at least 2 of them are imaginary. All right, so then we can say, okay, how many of you figured out that if Bob is a root, x minus Bob, x minus I, is a root, and then x plus I is a root? Raise your hand if you figured that part out. Awesome. And that's got, wait a minute, degree 3. Why? Because that's degree 1, degree 1, degree 1. That's degree 3. It's supposed to be degree 5. How do we make the last 2? Actually, any way you want. Because I didn't give you any evidence of how the last 2 roots look. Could those last 2 be imaginary? Yeah. There could be more imaginary roots. And by the way, if you actually multiply this out, this is important, that would be x squared, outside inside cancel, minus I squared, which is the same as, what's minus I squared? Minus -1, which would mean plus 1. Do you get that you might have to know that this is in your equation? Just like this was in your equation? Okay. And then the last 2 roots, I could make something up, like x minus 8 squared. Cool, I just made up the rest of it. Yes?
Do you have to add rows, or can you just like cube the first one or something?
You mean this number, the 3 in front, you mean?
No, the x minus 2. You just cube that and then there's 5.
Oh, I see what you're saying. Yes, that would be a way to do it. Instead of adding this x minus 8 quantity squared, I could say this whole thing is to the 3rd. I agree. In fact, you could even do that with this. You can even say that's to the 3rd. That'd be a way to get 2 more roots. I like it. Okay. What else do you have to know? Holy cow, we've covered so much stuff. Well, let's see if you've got what you're supposed to get so far. And I think you've got almost everything. If I give you this, you should be able to sketch it. You don't know exactly how it looks, but you know some stuff. Take a quick sketch of that. There are a lot of right answers because I've given you very little info. One thing, for sure it's going which way on the right? Down on the right. So if I draw mine in green here, is that humanly possible? No, because it's going up on the right. Can't possibly be right. This one, as far as being down on the right, and it's also down on the left, so far, is it possible that that could be the graph of it? Okay. What if I told you there could be more stuff, then this is possible. Like there could be other stuff like 3x squared plus 2x plus 1. But if the graph was only this red, then I know what the 0 is. The 0 is 0, very good. Then I know it has to go like that. And besides, if you just think what x to the 4th looks like, do you know x to the 4th is like a parabola? And then when you make it negative x to the 4th, it just flips it upside down. And this one hasn't been shifted left or right. All right. Now what if I said, oh, by the way, and it also has a root of I. One of the roots is I. Whoa, that changes everything then. Because that means that it has to have an x plus I and an x minus I in the equation. And when you multiply that out, that's x squared plus 1. Has to be in your equation somewhere. So this could just be the lead coefficient, and now I know that has to also be in my equation. And then we just did one like this a minute ago. Okay, last thing. Ooh, there's more? Yes. You have to know how to do synthetic. Let's do a plain old-fashioned factoring one first. Would you do a long division with 201, and this is 4. Does 4 go into 201? I hope you remember how to long divide. It's kind of embarrassing if your grandpa says, "So, Sonny, what math class are you taking?" And you say, "Oh, I'm in the honors pre-calc class." And he says, "Okay, so what's 201 divided by 4?" And you're like, "Well, I don't know how to divide." That's a little embarrassing. I know you've got a calculator for that, but you really do need to know your basics. Besides, in a minute, these are going to be polynomials. And then you can smack grandpa and say, "Well, what's x squared minus 4x plus 7 divided by x to the third?"
Should we really be slapping grandpa?
No, that was a metaphorical slap. We don't slap grandpas. You can hit him with that question. No, not actually hit. Like, challenge him with this hard math question. All right, so anyway, would you please say 5, and this is 20, and notice what you do is you go minus 20. Why? Inexplicably, we change that to the opposite sign. And then I have 0 left, and I bring down the 1. And then I say to myself, oh, it doesn't go into 1. I put a 0 here. Do you get that the answer is 50? But wait, it's kind of the answer is it doesn't work. So 50 remainder 1 is what you did when you were a little kid, but you're older now, so you don't say that. You say 50, and there's 2 ways to say it. Any thoughts? 50 and 1/4. Notice 1/4, which is the same as 50.25. That's true. Or you could say it's 50 and there's 1 left over, meaning 4 times 50 plus that. You get how that makes 201?
Sure.
All right, so let's see if you remember how to do synthetic division. First, let's do long division. And by the way, you have to be able to do both this year. In case you had forgotten, you start on the top of these things, and you usually start with an x and just see if it works. A lot of times it does, and it does in this case. And what did we do last time when we were dividing? We took this times this and put it here. So do that. And I know some of you are like, I never learned long dividing when I was young. Well, you're old now, and you're smarter, and you can learn it faster than you ever could. I guarantee you when they taught long division, it took at least a week before you were even kind of partially good at it. And you could handle it in 5 minutes with me and you and practicing. You could have long division down in 5 minutes. Okay, so this times this, x squared. This times this, x. Draw a line. Notice, remember we did opposite for no good reason? We just do opposite, opposite? It's true. Still do that. 2x. And wait, there's not enough. I'm bringing down this, plus 2. Goes on top up here. Plus what? Plus 2. Then the 2 can be multiplied by all that. Notice both parts. Can't just multiply by randomly one of them. You got to multiply the 2 by both of them. So it's 2x plus 2. Draw a line. Opposite, opposite. And it becomes 0. Yay, there's no remainder. And it worked. I did long division. We'll do one more long division before we do a synthetic. Okay? So here's another long division. See if you can handle it. Telling you, we're going to have to do this. You don't have to know this for the test. X to the I'm going to keep your life simple. I'm not going to make these super complicated. Actually, not even to the third. I'll just make it to the second for now because you can factor it. Oh, everybody can do this. Use long division to factor that. Pausing for a second. If at this point you didn't know how to start, you at least need to get started. I'll show you. You put an X there. Remember I said always start with an X up top, if nothing else. Try that. And then this times this. Oh, it's working. X squared minus X. Draw the line, and here's where a lot of people screw up because they think, oh, so I just go make this negative 6x. Nope, you forgot a critical step. Remember how we had to make it the opposite of? Opposite, opposite. Notice if it was negative, you have to change it to positive. It's like subtracting, except you're subtracting a negative makes it positive. Okay, so then this makes negative 4x plus 4. Feels like this isn't going to work, but I'm going to try. I'm going to put a minus 4 here, and I try multiplying it out. Negative 4 times the x is negative 4x. Negative 4 times, oh, the negative one makes it positive 4. Yay, it worked. Because when I change it to opposite and opposite, now these will cancel, and I get 0 remainder, and it worked. Can anybody tell me what the synthetic would be for this? In case you forgot, this is the only time when I ever used advice from Snoop Dogg.
Can you play that song again like you did?
I'm not going to take time to look it up, but what was the key lyric? Drop it like it's hot. This gets dropped down there. And then I multiply that times that. Add. Multiply. Uh-oh, I did something wrong.
It's 1 in the corner instead of negative 1. Yeah.
Oh, you got me. Remember this and this? And they have to be opposites so that the one would make the other. I did it. I did a bad thing. Positive 1 goes in the box. 1, negative 5, 4. Sorry. Drop it like it's hot. And then multiply. And then add. And then multiply. And then add. And awesome. Please stop talking. This is a 0 remainder. So therefore, what does this mean? In case this is, if you don't interpret them, you don't have anything. You've got to be able to interpret that as x minus 1. And you got to be able to interpret that as that's the x's. That's, I think you could say this is x to the 1 and this is like x to the 0 if you wanted to think of it that way. So there's like nothing there. So this is just x minus 4. And there, it's factored. All right. So I'll give you one last one. And this encapsulates everything that I've tried to teach you just now. Imagine for a moment they asked you to factor this and then be able to graph the results. Because do you get if you have x to the third plus 3x squared plus 3x plus 9 that you don't probably really know what that looks like? But if it was factored, you probably could tell it what it looked like. You'd know where it bounced and where it cut through, and you know all kinds of stuff. So how do you factor it? Well, they would give you this clue. Try x equals 3. Well, then you go like this. 3, 1, 3, 3, 9. Do it. See if you can do it. Snoop Dogg, eternal wisdom, drop it like it's hot. Then multiply, then add. 6. Then multiply, then add. Uh-oh, something went wrong. Oh, I remember. X equals 3 doesn't work. Now just guess what works. -3.
So X.
That's going to be your most common mistake. Don't laugh at me. On the test, you're going to goof up negatives like that too. But at least I caught it. You know why? Because I knew how to do synthetic, and I knew that I wasn't going to get a remainder of 0. So now I will. Try that one with a -3. Drop it like it's hot. Multiply. Add. Multiply. Add. Multiply. Add. 0 remainder. Sweet. And then, in case this hasn't made sense to you before, this is our constant, this is our x's, and this is our x squareds. Do I really have to write 0x? No, you don't. So then what does this equate to? That equates to x plus 3, very good. And this factor is x squared plus 3. And then I would say that's nice if you had been in higher algebra, but you are in honors pre-calc where you have to factor it all the way, including over the complex number system. 12-minute warning. So how come I can't just be done? Because this can be factored. You might be like, well, that only works if the 3 is like a 16 or a 9 or a something that has a perfect square, you know, like a 36. Nope, it still works. X plus 3 is a factor. Therefore, -3 is a root. X plus 3, X minus 3. But wait, that's going to make a 9, Mr. Server. So you go square root of 3, square root of 3. That'll make a 3. But wait, it's the wrong sign. Then you need an I. Very good. I here and I there. Oh, wait, I put it, sorry, not there. Here and here. I'll clean it up. Final answer, x plus 3, x plus I root 3, x minus I root 3. What are the roots? X equals -3, x equals negative I root 3 because of that, and x equals positive I root 3 because of that. And if you put it in there, it would make it equal 0, and that's the point. The factors, the factors give you the roots give you the zeros. That's a lot, I know. But I pretty much reviewed a month worth of higher algebra and helped you understand how I squareds and I's, and therefore complex numbers, could be involved. Now, I want to get to homework. Everybody get to this page right here. You're going to do this whole first page. But wait a minute, the first one doesn't factor. And they tell me to factor it. What? Can factor it? You should. What if you can't factor it? Use the quadratic formula, and then you are factoring it. At the end, you need answers that are factors. It's x minus Bob and x minus Bob. Do you get what I'm trying to do there?
Yeah.
I don't know what the factors are. The quadratic formula is going to tell me, and then I'll put them here and here. What if the answers are like 1 plus I? Well, then that's what you put here. 1 minus I. Well, then that's what you put here. It's going to be x minus and x minus. I guarantee you that. That's how you always start them. And then whatever the roots were from the quadratic formula, they go there and there. If you don't understand what I'm talking about, start by just doing the quadratic formula. And then remember, it's x minus Bob. Whatever Bob comes out of the quadratic formula as, 2 plus 3i, whatever it is, that goes there. And then that'll be your factor, like that. Okay. This one, that's not going to factor. So you use the quadratic formula. And turns out it does factor. You got two factors, x and x. And if you do the right thing, it's always minus and minus. Drop in the root in a parenthesis. Get those from the quadratic formula. What do you think you're going to use on number 31 that I just taught you moments ago and Snoop Dogg is good at? Synthetic. I know he's good at rapping, but that was not the correct answer. 1, 6, 6, 5. Draw the line. Drop it like it's hot. Oh, wait a minute. -5. Ah, poop. I always get confused on when I'm not confused. I do goof it up, though. It says x equals -5, so I should use -5. If they'd have said a factor was x plus 5, that would go with this. But I'm not using long division. I'm using synthetic. You could use long. If you wanted to, you could use long division. Then you'd say x plus 5 was on the outside. It would look like this. Oh, wait a minute. I have to write in the variables then. If you were going to do it with long, it would look like this. And that's an option. I personally think synthetic is easier. But I warned you, you'll have to be able to use both. Okay. Next page. Scribble out the one that says challenge for sure. But try the one on top. It's really not that bad. As soon as they said x equals I is one of the zeros, I'm like x plus I. And then I'm like, wait a minute. Doesn't there also come in, these come in packages too, so automatically, what's the other one? X minus I. So this tells you actually, because it only tells you one of them, but then it actually tells you the other one. Because you never get one without the other. It's kind of like a deer jumping across the road.
You can get just one deer.
Except with deer, you can get just one deer. But it's really true that a lot of times deer come in packs. You guys ever seen that before? You see one deer and it's like almost immediately, oh, there's another one. Because they're social little beasts, like to hang out. Lots of Instagramming going on. All right, on this one, I think the top two would be good enough, so scribble out this one. And that's it. This tells you that there's 1, 2, 3, 4 roots. This tells you the lead coefficient is that, so there must be one more root. Oh wait, it's right here. That's another root. It seems like 0 couldn't be a root, but it is. Remember, it's always x minus Bob. So x minus 0 is one of your factors. And then at the end, maybe you'll have an answer that's like this or something. I'm not saying that's the right answer. Just saying you'll have a sketch. All right, you've made it to the end. Be nice if tomorrow was Saturday, but it's not. Go one more day. Have you guys noticed that we have a whole bunch of full weeks in a row? Like 5-day weeks. What is this crap? I have to teach 5 days a week? Anyway, yeah, it's kind of a long stretch of full weeks. Then finally it caps off with Memorial. And then Memorial has that Monday off, of course. So that is 4-day week there. And the next week's a 4-day week too. So anyway, so we get some nice short ones at the end. But there's a long string of full weeks. So if you're a little tired, it's okay. This is the tough stretch, but you get through it. Okay. That was the second day of complex numbers. That's all I got for you for today. It doesn't really matter that much for me, so you can keep it.
I mean, I don't need it.
All right, I'll take care of it. Thank you. Thank you. Gotcha. So I was trying to tell if you wanted it or what. Piper Rodriguez. Remember, if you want to be excused coming in that late, you're going to have to get somebody to send me an email.
Okay, thank you.
Yep. Okay, what was that about? I'd say that was about roots.